Nvidia was the belle of the ball. Today's gain was yet another record high.
Nvidia has just unveiled its latest creation, and it's sending shockwaves through the tech world. Have you ever wondered what the future of computing might look like? The exceptional tech inside Nvidia's latest chips. To answer the question asked earlier, Nvidia's new Blackwell GPUs might just give us a glimpse. Let's dive into what makes these chips so special. At the heart of Nvidia's bold move to dominate AI computing, the Blackwell GPUs blend cutting-edge hardware with powerful software. This combination is set to revolutionize data centers, boosting efficiency to heights we've never seen before. The star of the show is the Blackwell B200, a chip that's pushing the boundaries of what we thought was possible with hardware.
This is Hopper. Hopper changed the world. This is Blackwell.
It's not just a small step forward, it's a giant leap. The B200 offers a staggering 10 to 25% improvement in performance over its predecessor, the B100, depending on the workload. And get this, it can consume up to 1,000 watts of power. That might sound like a lot, but when you consider what this chip can do, it's actually incredibly efficient. But how did Nvidia achieve this? It's not just about cramming more transistors onto a chip. The real magic lies in how these transistors are used. Nvidia has introduced a groundbreaking design where two semiconductor dies are joined in a way that's never been done before. This isn't just an improvement in technology. It's a completely new approach to GPU design. To put this into perspective, Nvidia's previous GPU, Hopper, had 28 billion transistors.
Grace Hopper has more memory on this one module than all of these. You don't have to break the data into so many pieces.
Blackwell uses even more, and each one is more efficient than ever before. This means faster processing, better energy efficiency, and the ability to handle more complex tasks than ever before. One of the most impressive features of the Blackwell chips is their ability to handle AI tasks. They're 4 times better at training AI models, and an incredible 30 times more efficient at AI inference tasks compared to Hopper. What does this mean in practical terms? Imagine you're trying to teach a computer to recognize faces in photos. The training part is when you show the computer thousands of pictures and tell it which ones have faces. Blackwell can do this 4 times faster than before. The inference part is when the computer uses what it learned to find faces in new photos it's never seen before. Blackwell can do this 30 times more efficiently. This means AI systems can learn faster and work better while using less energy. But Nvidia didn't stop there. They've also created something called the GB200 superchip. This powerhouse pairs 2 B200 GPUs with 1 Grace server CPU. They're connected by something called NVLink, which has a transfer speed of 900 GB per second. To put that in perspective, it's so fast it can transfer 150 full-length 4K movies from one chip to another in just a second. Now, you might be wondering, why do we need all this power? Well, as our world becomes more digital, we're creating and using more data than ever before. From social media posts to scientific simulations, all this data needs to be processed, analyzed, and stored. That's where these powerful chips come in. They can handle these massive amounts of data faster and more efficiently than anything we've seen before. But Nvidia's ambitions don't stop at just making faster chips. They're looking to revolutionize entire industries. These new GPUs could be the key to advancements in self-driving cars, more realistic video games, better weather predictions, and even help in the search for new medicines. The Blackwell chips are also designed with the future in mind. As we move towards more advanced AI systems, we'll need chips that can handle increasingly complex calculations. Blackwell is built to meet these future demands. potentially paving the way for AI breakthroughs we can't even imagine yet. However, with great power comes great responsibility. As these chips become more powerful, they also consume more energy. Nvidia has worked to make them as efficient as possible, but the energy demands are still significant. This raises important questions about the environmental impact of our ever-growing digital infrastructure. Moreover, as these chips become more advanced and expensive, there's a risk of creating a digital divide. Not every company or research institution will be able to afford this cutting-edge technology. How will this affect innovation and competition in the tech industry? And we marvel at the exceptional tech inside Nvidia's latest chips. We can't help but wonder, what will be the real-world impact of this technological leap? Will it truly revolutionize industries as Nvidia claims? Or are there hidden challenges we haven't considered yet? The high stakes of Silicon Valley's tech gambles. In the heart of Silicon Valley, a high-stakes game is unfolding. Tech giants are placing bets that could reshape our digital future. At the center of this thrilling race is Nvidia, a company that's not just playing the game, they're changing the rules. Remember when Nvidia was just known for making graphics cards for gamers? Those days are long gone. Now they're aiming to be the backbone of the AI revolution. But here's the million-dollar question. Can Nvidia outpace tech titans like Apple and Microsoft? Nvidia's latest move in this high-stakes game is the introduction of their Blackwell platform. Nvidia is saying, we're not just here to compete, we're here to lead. So what makes Nvidia think they can take on the big players? It all comes down to their comprehensive approach. They're building an entire ecosystem for AI computing. This means creating hardware that works seamlessly with software, all designed to push the boundaries of what's possible with artificial intelligence. But here's where it gets really interesting. Nvidia isn't just focusing on one area. They're spreading their bets across multiple sectors. We're talking about autonomous vehicles, supercomputing, humanoid robots, and even digital twins. For industrial applications, it's like they're playing chess while everyone else is playing checkers. However, this ambitious strategy comes with its own set of risks. Each of these areas presents unique challenges, from regulatory hurdles to market readiness. It's like trying to juggle while riding a unicycle. Impressive if you can pull it off, but one wrong move and everything could come crashing down. Let's break down one of these bets. Autonomous vehicles. Nvidia's technology could be the brain-powering self-driving cars of the future. Sounds exciting, right? But think about all the variables involved. You need sensors that can detect everything around the car, powerful processors that can make split-second decisions, and software that can handle any situation the car might encounter. And that's not even considering the legal and ethical questions surrounding autonomous vehicles. Now multiply that complexity across all the sectors Nvidia is targeting. It's a massive undertaking that requires not just technical prowess, but also strategic foresight and the ability to navigate complex regulatory landscapes. But here's where Nvidia's gamble gets even bolder. They're not just developing technology, they're trying to position themselves as the essential supplier in a rapidly growing industry. This strategy is evident in their approach to data centers. Nvidia's new chips promise to make data centers more efficient and powerful. If they can deliver on this promise, they could become an indispensable part of the digital infrastructure that powers our online world. However, this position comes with its own challenges. As Nvidia's chips become more advanced and more expensive to produce, they're walking a tightrope between innovation and affordability. They need to keep pushing the boundaries of what's possible, while still making products that companies can actually afford to buy and use. This balancing act is crucial because Nvidia isn't operating in a vacuum. Other tech giants are also making big bets on AI and advanced computing. Companies like Google, Amazon, and even traditional chip makers like Intel are all vying for a piece of the pie. So how does Nvidia plan to stay ahead? One key strategy is their focus on software. They're not just making powerful hardware, they're creating tools and platforms that make it easier for developers to use that hardware effectively. This software focus is evident in their CUDA platform, which allows developers to use Nvidia's GPUs for a wide range of computing tasks, not just graphics. By making their hardware more versatile and easier to use, Nvidia is trying to create an ecosystem that's hard for competitors to replicate. But perhaps the most interesting aspect of Nvidia's strategy is their focus on AI. They're betting big that AI will be the next big revolution in computing, and they want to be at the forefront. Their chips are designed not just to run AI programs, but to train them, a process that requires enormous computing power. This focus on AI training could be a game changer. As more companies look to implement AI in their products and services, they'll need the kind of powerful, efficient hardware that Nvidia is producing. If Nvidia can establish itself as the go-to provider for AI hardware, they could secure a dominant position in the tech industry for years to come. But with great ambition comes great risk. Nvidia is investing heavily in research and development, betting that the demand for their advanced chips will justify the high costs of producing them. If they're right, the payoff could be enormous. But if they're wrong, or if the market doesn't grow as quickly as they expect, they could find themselves overextended. There's also the question of competition. While Nvidia is currently leading in many areas of AI and high-performance computing, other companies aren't standing still. Tech giants like Google and Amazon are developing their own AI chips, potentially reducing their reliance on Nvidia's products. Moreover, as AI becomes more prevalent, there are growing concerns about its impact on society. Issues like data privacy, algorithmic bias, and the potential for job displacement are becoming increasingly important. As a leader in AI technology, Nvidia will need to navigate these ethical and societal challenges alongside their technical ones. Despite these challenges, Nvidia's bold strategy has many investors and industry watchers excited. They see a company that's not content to rest on its laurels, but is instead pushing aggressively into new frontiers of technology. But perhaps the most fascinating aspect of Nvidia's journey is what it tells us about the future of technology. In a world where data is becoming increasingly important, the companies that can process and analyze that data most effectively will have a significant advantage. As we watch Nvidia's high-stakes gamble unfold, we're left with a crucial question. Are we witnessing the rise of a new tech superpower, or are we seeing a company overreach in its ambition? The answer could shape the future of not just Nvidia, but the entire tech industry. Next, let's turn our attention to another aspect of this technological arms race. In the world of supercomputing, where raw power meets practical application, what dark realities might we uncover? The dark reality of modern supercomputing. In the world of technology, few things capture the imagination quite like supercomputers. These behemoths of calculation promise to unlock the secrets of the universe, revolutionize medicine, and push the boundaries of artificial intelligence. But beneath the glossy exterior of flashing lights and humming processors lies a darker reality that few outside the industry ever see. On the surface, the benefits seem clear. Supercomputers help us model climate change, design safer vehicles, and even predict natural disasters. They're the unsung heroes behind many of our modern scientific breakthroughs. Yet, as we delve deeper into the world of supercomputing, we uncover a landscape fraught with challenges and ethical dilemmas. One of the most pressing issues facing modern supercomputing is its voracious appetite for energy. These machines don't just run on electricity, they devour it. A single supercomputer can consume as much power as a small town. As we push for ever more powerful machines, we're faced with a troubling question. Are we solving problems at the expense of creating new ones? The environmental impact of these energy-hungry giants extends beyond just high electricity bills. The carbon footprint of data centers, where many supercomputers reside, is growing at an alarming rate. Some estimates suggest that by 2025, they could account for up to 3.2% of global carbon emissions. That's more than the entire aviation industry. But the challenges don't stop at energy consumption. The race for computing supremacy has created a new kind of arms race, with nations fighting for the title of fastest supercomputer. This competition drives innovation, but also raises concerns about the militarization of technology. Supercomputers play a crucial role in simulating nuclear explosions and designing weapons systems. As these machines become more powerful, the line between scientific research and military application, concentration of such immense computing power in the hands of a few raises questions about equality and access. Supercomputers require massive investments, both in terms of money and expertise. This means that only wealthy nations and large corporations can afford to build and maintain them. The result? A widening technological gap that threatens to leave developing nations and smaller organizations behind. But perhaps the most unsettling aspect of modern supercomputing lies in its potential to reshape our understanding of privacy and security. These machines excel at crunching vast amounts of data, making them ideal tools for surveillance and data mining. In the wrong hands, a supercomputer could become an Orwellian nightmare, capable of tracking and analyzing the behavior of millions of people in real time. Consider this scenario. A government uses a supercomputer to analyze social media posts, surveillance camera footage, and financial transactions of its citizens. With enough data and computing power, it could potentially predict and manipulate social trends, or even identify and target dissidents before they take action. This is a very real possibility that we must grapple with as supercomputers become more powerful and ubiquitous. The ethical implications extend even further when we consider the role of supercomputers in artificial intelligence research. As these machines become better at processing and learning from vast amounts of data, we edge closer to the possibility of creating truly intelligent machines. But are we prepared for the consequences? A super-intelligent AI running on a supercomputer could solve many of humanity's problems, or it could pose an existential threat if not properly controlled. Yet for all these challenges, supercomputers remain an indispensable tool in our technological arsenal. They help us tackle some of the most complex problems facing humanity. From unraveling the mysteries of dark matter to developing new medicines, supercomputers are at the forefront of scientific discovery. Take climate modeling, for instance. Supercomputers allow scientists to create incredibly detailed simulations of Earth's climate systems. These models help us understand how different factors interact to influence global weather patterns, allowing us to make more accurate predictions about the future of our planet. Without supercomputers, our ability to understand and mitigate climate change would be severely limited. In the field of medicine, supercomputers are revolutionizing drug discovery. By simulating the interactions between drugs and human cells, these machines can help researchers identify promising new treatments much faster than traditional methods. This could lead to breakthroughs in treating diseases like cancer, Alzheimer's, and even future pandemics. Supercomputers also play a crucial role in fundamental physics research. The Large Hadron Collider, the world's largest particle accelerator, relies on supercomputers to analyze the vast amounts of data generated by its experiments. This has led to groundbreaking discoveries, such as the confirmation of the Higgs boson, which helps explain how particles acquire mass. But as we push the boundaries of what's possible with supercomputing, we're also running up against the limits of traditional computing technology. The chips that power our current supercomputers are approaching the physical limits of how small and fast they can be. This has led to a new frontier in computing, Quantum computing. Quantum computers promise to solve certain types of problems exponentially faster than even the most powerful traditional supercomputers. They work by harnessing the strange properties of quantum mechanics, allowing them to perform many calculations simultaneously. While still in their infancy, quantum computers could potentially revolutionize fields like cryptography, materials science, and financial modeling. However, the advent of quantum computing brings its own set of challenges. The same properties that make quantum computers so powerful also make them incredibly difficult to build and maintain. They require extreme conditions, operating at temperatures colder than outer space, and are highly sensitive to environmental disturbances. Moreover, the potential of quantum computers to break current encryption methods poses a significant threat to cybersecurity. This has sparked a race to develop quantum-safe encryption methods that can withstand attacks from future quantum computers. As we stand on the brink of this new era in computing, we're faced with a complex situation of promise and peril. Supercomputers and their quantum cousins offer unprecedented opportunities to advance science and solve global challenges. Yet they also present risks that, if not carefully managed, could lead to unintended and potentially catastrophic consequences. The dark reality of modern supercomputing is not that these machines are inherently dangerous, but that their power amplifies both our greatest aspirations and our deepest flaws. They are a mirror, reflecting back at us the complexities and contradictions of human nature. As we continue to push the boundaries of what's possible with supercomputing, we must also grapple with the ethical and societal implications of these technologies. How do we balance the need for scientific progress with concerns about privacy and security? How can we ensure that the benefits of supercomputing are distributed equitably? And perhaps most importantly, how do we maintain control over machines that may one day surpass our own intelligence? Tackling global challenges through innovation. In an era where technology's environmental footprint and privacy concerns loom large, tech giants are stepping up to address these critical issues. Leading the charge is Nvidia, alongside other industry heavyweights, each bringing unique solutions to the table. Nvidia's approach to environmental sustainability is multifaceted. One of their most promising initiatives is the development of AI-optimized data centers. These facilities use advanced liquid cooling systems that not only reduce energy consumption, but also allow for the capture and reuse of heat. In their Voyager data center, Nvidia has implemented a direct-to-chip liquid cooling system that's 30% more energy efficient than traditional air cooling methods. This technology allows them to run high-performance computing tasks while significantly reducing their carbon footprint. Moreover, Nvidia is leveraging its AI expertise to optimize power grids. Their AI models can predict energy demand and supply, allowing for more efficient distribution of renewable energy. In a pilot project with a major European utility company, Nvidia's AI system improved renewable energy forecasting accuracy by 12%, leading to a substantial reduction in reliance on fossil fuel backups. On the privacy front, Nvidia is pioneering federated learning techniques. This approach allows AI models to be trained on sensitive data without the data ever leaving its source. For instance, in healthcare applications, patient data can remain securely within hospital systems while still contributing to the development of advanced diagnostic AI tools. Nvidia's FLAIR, or Federated Learning Application Runtime Environment Platform, is being used by research institutions worldwide to collaborate on AI projects without compromising data privacy. Another tech giant making big strides in these areas is Microsoft. Their AI for Earth program is applying cloud computing and AI to solve global environmental challenges. One notable project uses AI to analyze satellite imagery to track deforestation in real time, allowing for rapid response to illegal logging activities. Microsoft has also committed to being carbon negative by 2030, and they're on track with innovative carbon capture technologies. Microsoft's approach to privacy includes the development of differential privacy techniques. This mathematical framework adds carefully calibrated noise to data sets, making it impossible to identify individuals while still allowing for accurate analysis of aggregate data. They've implemented this in products like Windows, ensuring user telemetry data remains anonymous. Google, another key player, is pushing the boundaries of sustainable computing. Their DeepMind AI has been applied to Google's own data centers, reducing cooling energy consumption by 40%. They've also developed the world's first temporal carbon-aware computing platform, which schedules compute-intensive tasks to times when low-carbon power sources like solar and wind are most available. In terms of privacy, Google is developing privacy sandbox technologies for the web. This initiative aims to phase out third-party cookies and replace them with more privacy-preserving alternatives for ad targeting and conversion measurement. Their FLOC, or Federated Learning of Cohorts technology, groups users with similar interests, allowing for personalized ads without individual tracking. Amazon, with its vast cloud infrastructure, is also making significant contributions. They've pledged to power their operations with 100% renewable energy by 2025, 5 years ahead of their original target. To achieve this, they're investing in large-scale wind and solar projects globally. In Virginia alone, Amazon's solar projects will generate enough energy to power 80,000 homes annually. On the privacy front, Amazon Web Services offers a suite of tools for data protection and compliance. Their Macy service uses machine learning to automatically discover, classify, and protect sensitive data in the cloud. This helps organizations maintain privacy standards and comply with regulations like GDPR and CCPA. Apple, known for its hardware, is taking a unique approach to sustainability. They've developed a custom alloy for iPhone enclosures that's 100% recycled, reducing the need for mining new materials. They're also pioneering the use of recycled rare earth elements in their devices, a significant step given the environmental impact of rare earth mining. Apple's privacy initiatives are equally innovative. Their app tracking transparency feature gives users control over which apps can track their activity across other companies' apps and websites. They've also introduced Hide My Email and private relay services, which create unique random email addresses for sign-ups and encrypt internet traffic, respectively. These tech giants are not just working independently, but are also collaborating on key initiatives. The Climate Pledge, co-founded by Amazon, has brought together over 300 companies committed to reaching net zero carbon emissions by 2040. Similarly, the Digital Trust and Safety Partnership, which includes Google, Microsoft, and others, is working to develop industry-wide standards for online safety and privacy. While these efforts are commendable, challenges remain. The exponential growth of data and the increasing complexity of AI models mean that energy demands continue to rise. Privacy concerns evolve as fast as the technologies designed to address them, requiring constant innovation and vigilance. As we look to the future, Nvidia stands out as a key player in this technological revolution. Their latest invention, the Hopper architecture, promises to deliver unprecedented AI performance while significantly reducing energy consumption. This could be a game changer for the industry, enabling more powerful and efficient AI applications across various sectors. Ultimately, the tech industry's giants are proving that innovation and responsibility can go hand in hand. By addressing environmental and privacy concerns head-on, they're not just securing their own futures, but also contributing to solutions for some of humanity's most pressing challenges. As Nvidia and its peers continue to push the boundaries of what's possible we can expect to see even more groundbreaking solutions emerge, shaping a more sustainable and privacy-conscious digital future.
How Nvidia's Hopper redefines computing. Nvidia's newest AI processor is creating a lot of excitement in the tech world, breaking through limits that were once thought to be impossible. This isn't just a small improvement, it's a major shift that is changing how we see technology. The buzz is all about the Hopper architecture, which has reshaped the competitive landscape. With performance leaps that dwarf its predecessors, the Hopper architecture is setting a new standard, leaving other processors struggling to keep up. But what if this is just the beginning? Could this unprecedented power reshape industries overnight, rendering entire technologies obsolete? Stay tuned, because the future of computing is about to take an unexpected turn. This AI processor is a game changer, challenging even some of the basic principles of physics. Only 4 companies in the world have managed to create something like this: Microsoft, Apple, Google, and the company based in California, which saw its market value skyrocket from $1 trillion to $2 trillion in just 8 months. This huge jump came from the high demand for its cutting-edge technology, which is leading today's AI revolution. It's amazing to think that the company, which started in 1993 to make video game graphics better, has now become a major player in the AI world in the 21st century. In March of 2022, the Hopper architecture, designed especially for data centers to support AI work, was revealed. This launch created a lot of excitement in the AI community and led to strong demand. But the real surprise came in 2023, during the AI boom, when prices for these products shot up due to shortages and heavy demand. People who ordered H100-based servers had to wait between 36 and 52 weeks to receive them. Despite these delays, the company still managed to sell 500,000 H100 accelerators in just the third quarter of 2023. The strong position in the AI market and the success of its Hopper products played a big part in boosting the company's market value. However, this wasn't the end of the big moves. Looking to the future, the Blackwell architecture, named after the famous American mathematician David Blackwell, was introduced. Blackwell made groundbreaking contributions to fields like game theory, probability, and statistics, and his work has had a huge impact on AI models and how they're trained. Interestingly, he was also the first African American to be inducted into the National Academy of Sciences. In October 2023, the updated plans for data center technology at an investor event were revealed. They introduced the B100 and B40 accelerators, part of the new Blackwell architecture. This was a change from their earlier plans, which called the next step after Hopper just Hopper Next. Later, on March 18, 2024, Blackwell was officially introduced at the Graphic Technology Conference, GTC. Over 11,000 people attended the event, including software developers, industry experts, and investors. It was held over 4 days at the Pro Hockey Arena in San Jose, and the main speaker was the CEO, Jensen Huang. Huang explained that Blackwell is more than just a chip, it's a full platform. The company is famous for its GPUs, but Blackwell takes things a step further. At the core of this technology is Hopper, which is currently the best GPU technology with an incredible 28 billion transistors. What makes it unique is its architecture, which, for the first time, combines 2 dies into 1 chip that communicates at a mind-blowing speed of 10 terabytes per second. It does this without facing memory or cache problems, acting as one large chip. Some people were doubtful about reaching such ambitious goals with Blackwell, but the company pushed forward and created a chip that fits perfectly into 2 different systems. One system works easily with Hopper for smooth upgrades, while the other, shown on a prototype board, demonstrates its powerful features and future possibilities. Imagine a system with 2 Blackwell chips and 4 Blackwell arrays, all connected to a Grace CPU through super-fast connections. This setup could change the world of computing. Let's see how this new technology packs powerful computing into a small space. A glimpse into next-gen AI computing. Huang highlighted that this system is groundbreaking because it packs so much computing power into a small space. However, the company didn't stop there. To truly push the boundaries, they added new features that challenge the limits of physics. They introduced the 5th-generation NVLink inside the new Transformer engine, which is twice as fast as Hopper and enables computing within the network itself. This is important because when several GPUs work together, they need to share and sync data efficiently. With this innovation, the company is setting a new bar in technology. The new AI supercomputer is built with incredibly fast connections that allow it to handle data right inside the network, making it much more powerful. Even though it's officially rated at 1.8 terabytes per second, it actually performs even better than that, making it faster than the Hopper model. This new chip improves training speed by 2.5 times compared to Hopper, thanks to its new FP6 format. It also comes with FP4, which makes tasks like quick responses and predictions happen twice as fast. These improvements are not just about speed. They help save energy, reduce the amount of data that needs to travel through the network, and save time, which is becoming more important as AI technology grows. The company calls this phase generative AI because it represents a big shift in how technology works. The newest processor is designed for this change, using FP4 to quickly create content. It's part of the AI supercomputer and can produce 5 times more output than the older Hopper model. But that's not the most impressive part. The company is already working on an even bigger and stronger GPU that will go beyond what's possible now. This new chip, which includes the NVLink switch, has 50 billion transistors, almost as many as the Hopper model. It also has 4 NVLinks, each running at 1.8 terabytes per second, allowing all the connected GPUs to work together at their top speed. This is a huge step forward, pushing the boundaries of what computers can do today. If you look back 6 years, the first DGX-1 could handle 170 teraflops, or 0.17 petaflops. Fast forward to now, and the company is aiming for 720 petaflops, getting closer to reaching 1 exaflop for training. This is a massive achievement, making it the world's first exaflop machine, all in one system. To give you some background, only a few machines in the world today can reach exaflop levels of computing. This DGX isn't just another AI tool, it's a powerhouse, all neatly packed into a single sleek rack. But what makes this possible? It's thanks to the NVLink backbone, which provides an incredible bandwidth of 130 terabytes per second. To put that in perspective, this speed is faster than the entire internet combined. And it does this without needing expensive optics or transceivers, which also helps save a lot of energy. About 20 kilowatts in a system that usually uses 120 kilowatts. The system keeps a steady temperature of 25 degrees Celsius while it's working, with the help of air conditioning. The water that comes out is around 45 degrees Celsius, similar to the temperature of a hot tub, and flows at a rate of 2 liters per second. This setup ensures everything stays cool and runs smoothly. Now, let's talk about an important part of this system, the GPU. While some might see it as just another component, for Nvidia, it's a game changer. The days of clunky GPUs are over. Modern GPUs are incredibly complex, made up of about 600,000 parts and weighing around 3,000 pounds. That's about 1.5 tons. Pretty amazing, right? Now, let's see how these tech upgrades make training AI faster and more efficient. Powering AI with less. Training a GPT model with 1.8 trillion parameters is a huge challenge. Not long ago, this process could take several months and use a lot of energy. But thanks to advances in technology, especially in GPU architectures like the Hopper and, more recently, the Blackwell architecture, things have changed dramatically. With the Hopper architecture, training models of this size required 8,000 GPUs and about 15 megawatts of power, and the whole process took about 90 days. This was already a big improvement over older setups that needed even more resources. But then came the Blackwell architecture, which took things even further. Now, the same task can be done with just 2,000 GPUs and only 4 megawatts of power, making everything much more efficient. The Blackwell architecture has several upgrades that focus on reducing energy use while boosting performance. It includes a second-generation transformer engine, which optimizes processing by using as little as 4 bits per neuron in the neural network. This doubles the compute bandwidth, allowing faster processing of large language models without increasing energy consumption. But this wasn't the most impressive part. Blackwell's NVLink switch also improves GPU communication. It can handle up to 1.8 terabytes of traffic in each direction and can support up to 576 GPUs, compared to Hopper's limit of 256. The raw power of the Blackwell B200 model is also noteworthy, delivering up to 18 PFLOPS for certain tasks and boasting a memory bandwidth of 8 terabytes per second, making data transfer and processing lightning fast. These GPUs aren't just about raw power, though. They are designed to handle complex scientific computing and simulations. For example, Blackwell GPUs can run simulations for things like heat, airflow, and power use in virtual models of data centers. This ability can speed up such simulations by up to 30 times compared to traditional CPUs, making everything more energy efficient and sustainable. And there's more. The high bandwidth memory and advanced tensor cores in these GPUs allow them to handle even the toughest AI training and inference tasks. This makes them suitable for a wide variety of applications, from scientific research to enterprise AI solutions. The real breakthrough here is not just in cutting down the resources needed to train large models, but also in showing how quickly AI hardware is evolving to keep up with the growing complexity of AI tasks. At the center of the Groot project is Isaac Lab, a unique platform created by the company for training robots. Using Omniverse, Isaac's Sim, which allows for simulations, Isaac Lab gives robots a virtual space to practice and improve their skills, helping them get better at handling real-world challenges. Working alongside Isaac Lab, Blackwell is set to become the company's biggest product launch yet. As we explore the world of robotics, it's clear this technology is about to make a huge impact. The company is stepping into the fascinating world of physical AI, where machines can interact with the real world. Up until now, AI has mainly worked in the digital space, limited to systems like DGX. But imagine a future where AI goes beyond that, where robots have their intelligence and can move around the physical world on their own. This is what the company calls the robotics ChatGPT moment. The company has been hard at work developing advanced robotics systems, including AI training from DGX and AGX, the world's first robotic processor designed to handle high-speed sensor data in an energy-efficient way. Next, we'll explore how these advancements are shaking up the world of robotics. Bridging virtual realities and robotics. The company's Omniverse is a platform that connects the virtual and real worlds using Azure cloud services. Imagine a warehouse that runs on its own, where people and machines work together smoothly. In this setup, the warehouse works like a traffic controller in the sky, making sure everything moves safely and in order. What's even better? You can interact with this modern warehouse right away. Each machine has its own robotic system, making the whole process more efficient. Thanks to Blackwell's leadership, it feels like robotics are closer than ever. But the journey doesn't end here. Let's take a closer look at the progress being made in robotics. We are getting closer to the age of humanoid robots, and it's expected that robots will soon be taking over different industries. They can offer a safer and more efficient way of working. One industry that's about to see a big change is the car industry. Next year, the company plans to team up with Mercedes, and later with JLR, to introduce its latest technology. The company's CEO, Jensen Huang, also announced that BYD, the world's largest electric vehicle maker, will use the company's newest creation, Thor. Thor is a powerful computer system designed for advanced machines. This could change the world of robotics and might even lead us closer to having humanoid robots. But this isn't the most exciting part yet. Nvidia's Groot project is one of the most exciting projects in the world of robotics. It aims to change how robots learn and interact with their surroundings. The company isn't just thinking about these ideas, they are making them a reality. The Groot project is a huge step forward, giving robots the ability to follow complex instructions and learn from their past experiences. With advanced algorithms, these robots can decide what to do next on their own, making the connection between human instructions and robotic actions even better. But that's not the end of it. There's still more to come. Osmo is a new platform that helps organize and run training sessions and simulations more efficiently. It uses powerful DGX and OVX systems to ensure everything goes smoothly. One of the most impressive things about the Groot project is how it can learn with very little help from people. By watching just a few examples, robots equipped with Groot technology can perform everyday tasks and copy human actions with great accuracy. This is made possible by advanced technology, which uses complex systems to understand what people do and turn those actions into tasks that robots can perform. But that's not all. The technology doesn't just make robots move, it also helps them understand and respond to spoken commands, making them even more useful and easy to interact with. Whether it's simple gestures or more complicated tasks, robots using Groot technology show a lot of intelligence and flexibility. This is thanks to Jetson Thor robotic chips, which were designed specifically to power these advanced robots. The Groot project's impact goes beyond cool features. It is leading the way in robotics, bringing us closer to a future where robots are a normal part of daily life, transforming industries and how we use technology. The commitment to cutting-edge technology promises a bright future for humanoid robots with endless possibilities. Looking back, the journey started in the 1990s, when technology was quite different. Personal computers were just starting to become popular, but graphics were very basic, often limited to text and simple images, unless used for special purposes like animation or engineering. For better graphics, people relied on video game consoles. However, 3 engineers from California, Jensen Huang, Chris Malachowski, and Curtis Preem, had a different vision. They wanted to create a special chip that could handle more complex graphics on personal computers. Let's step back and see how it all started with a game-changing idea in GPU tech, the birth of Nvidia and the GPU. After many long brainstorming sessions, often at a local diner, they realized that while regular computer processors, CPUs, were good at handling one task at a time, creating 3D graphics for games needed something that could handle many tasks at once. Their solution was a new type of chip that could process tasks in parallel, which changed the world of computing. This chip, later known as the GPU, wasn't meant to replace the CPU, but to work alongside it, especially for graphics-heavy tasks. But that wasn't the hardest challenge. In its early days, the focus was on making PC gaming better, a market that was quickly growing. The company was founded in 1993 in a small condo in Fremont, California, and its main goal was to bring parallel processing GPUs into regular household computers. The name Nvidia comes from NV, short for next version, and Nvidia, the Latin word for envy. The green in their logo was chosen because their powerful chips were meant to make others envious. The company was started by 3 skilled engineers. Jensen Huang, a Taiwanese-American electrical engineer, had a lot of experience from working as the director of coreware at LSI Logic and designing microprocessors at AMD. Chris Malachowski brought in valuable engineering skills from his time at HP and Sun Microsystems. Curtis Preem, on the other hand, had designed graphic chips at IBM and Sun Microsystems. Even with all their expertise, starting a new company wasn't easy. In 1993, the 3 founders reached a point where they weren't sure how to move forward. To help them navigate the legal side of things, they decided to hire a lawyer. Jensen Huang only had $200 at the time, but he chose to invest this small amount to officially start the company. This initial investment not only got the company incorporated, but it also gave Huang a 20% stake in it. However, this was just the beginning of their journey. The next big challenge was getting enough money to turn their ideas into reality. Convincing investors was not easy because many venture capitalists preferred to back founders who already had successful businesses and a clear, exciting vision. Still, the company eventually caught the attention of Sequoia Capital and Sutter Hill Ventures, securing $20 million in funding. Looking back, it's clear how important those early investments were. Huang's connection with the CEO of LSI Logic came in handy, helping them secure a meeting with Sequoia Capital, the same firm that had also invested in LSI Logic. Although Sequoia was initially unsure, they eventually recognized the potential in the graphics card market and decided to invest. They first put in $2 million, which was later increased by an additional $18 million, putting the company on the path to success. But this wasn't the hardest part yet. Back then, investing was seen as risky. Out of 89 companies with similar goals, only AMD and the company survived the intense competition. By the time it went public in 1999, its value shot up to $600 million, proving the early investors had made a smart bet. But we're getting ahead of the story. The company was still a small group of engineers working hard to launch their first product. With the funding secured, it took 2 more years to build a team and create their first product, the NV1, which came out in 1995. During this time, the company made a deal with Sega to produce chips for their gaming consoles. These chips powered popular games like Virtua Fighter and Daytona. Interestingly, the NV1 chips were also compatible with PCs, allowing players to enjoy Sega Saturn games on their computers, an exciting concept for its time. The company took a bold step in how they designed the NV1 chips, using a rendering method based on quadrilaterals instead of the more common triangles. The goal was to speed up the rendering process by lightening the load on the CPU. In theory, this would use fewer polygons and better capture rounded shapes, giving game designers more creative freedom. But as technology advanced and memory became cheaper, this method became less effective and even caused compatibility issues since it didn't work with OpenGL. Could quadrilateral rendering make a comeback with today's tech? Like, comment, and don't forget to subscribe for more discussions.